Hello there, I'm Thomas.Hatsios, German American pilot flying the Boeing 787-900 tonight flight. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an Lszh localizer landing zone, and I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and the March Flight Simulator X. I'm going to start showing you how the cockpit instruments, the displays, and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the ground speed, um, the altitude, the vertical rate of climb distance of the aircraft in 10,000 feet per minute, or the stiffness of the trigonometric angles in degrees can climb descent. We have also the artificial horizon with the altitude indicator, the pixel degrees, and the bank angle in degrees. We have the Lszh localizer. We have the horizontal localizer, the vertical glide slope. We have the runways we use for takeoff and for landing. We have the threshold of distance that transmit the radio frequency that is unique for each runway we use for takeoff and for landing, and also magnetic north pole heading we have to align the aircraft with for the localizer, and also the angle of approach. So we have the onboard antennas of the aircraft that receive the Lszh localizer, the instrument landing system of the airport, the Lszh system. So it displays the horizontal localizer, the vertical glide slope, and we can tune either manually or automatically when we select the runway for takeoff or for landing from the flight management computer. We have also the Lszh localizer crossbars. We have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have the angle of attack of the aircraft as it flies on the flight mode 1 and 0 with the autopilot and the auto throttle. Later vertical navigation modes. We have also the HSI, the horizontal situation indicator with the magnetic heading and track. That displays also the HSI. We have the magnetic heading and track. We have the display of the flight plan, the integrated display of the flight plan. We're gonna create a flight plan using the management computer. I will input the data of the route, and we're gonna fly one waypoint by another, either manually or automatically. You will see later we can connect the autopilot in the flight plan route and fly with that in the LNAV, the VNAV mode. So we have also the navigation display. The navigation display that displays the GPS position of the aircraft, the magnetic north pole, the geographic north pole, and the magnetic variation depending on where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the terrain around you and below you, displayed with a red, green, and yellow amber color indication. Also, the lakes, the rivers, and the sea displayed with blue. We have the airports where they are located, our own airport, other airports with a 4-letter account name, the runways we're going to use for takeoff, for landing, the taxiways, and also the airport maps. You will see the airport map, our own airport map in the end part of the video. We have also the navigation aids, the nav aids, the board stations, ADFs and Bs, the waypoints which are horizontal vertical navigation fixes and altitude and airspeed constraints. You're gonna have to fly through some waypoints. So I'm gonna show you how to select some from the flight management computer when we create the flight plan over here. So you will see the flight plan here later. We have the horizontal, the vertical profile, the flight management, the primary flight display over here with the HSI and the flight mode announcer. So you will see in the navigation display we have also the display of other aircraft that fly around our own aircraft using the transponder, the DSP and ADC transmitter receiver, the transmitter radio frequency to other aircraft, and the air traffic control and receives from other aircraft. You can calculate using the radio frequency and its computer where the other aircraft is located, distance from our aircraft when we fly, the altitude difference in hundreds and thousands of feet, how many feet is above or below us, and also whether the other aircraft is climbing or descending the respective aircraft. You can also calculate the velocity closing in between aircraft and the other aircraft. It will give us warning from the TICA system, the traffic collision advisory system. If we have an incoming collision in the air, we make an avoidance maneuver. So we have also the display, the diamond shape of other aircraft in the navigation display. We have also the display of other aircraft in the runways, the taxiways, and the airport aprons from the TICA system, the track collision advisory system. So you're gonna see all the systems of the aircraft of the Boeing 787 before we go into flight, full manual flight. In the end part of the video, I will make also an engine start down demonstration. So you're gonna stay over here, you will see how we're gonna set up all the data that we need over here. Also I have over here you can see the flight controls. So I will show you how to use the flight controls, the keyboard that I need, and the mouse pad over here to input all the data and control the function of the switches over here in the displays. So we have the side stick for this to control the yoke of the Boeing 787. I have a side stick identical to the Airbus aircraft, so we can climb, descend, make turns to the right, to the left using control wheel. Also the rudder pedals, we control the vertical rudder and also the nose wheel steering, the vertical rudder in flight and the nose wheel steering in the ground together with the rudder. So we have also the tiller over here for the nose wheel steering. So you can see we have the thrust levers over here, so I can actuate the thrust. We have the horizontal trim stabilizer, so you can see the thrust levers position increase or decrease like this. You will see if I reach a takeoff, warning will sound and display here red warning that will not configured for takeoff right now. So you can see the engines, left and right engines. I will talk to you about in a couple of seconds. You can see the display, primary flight display over here. The horizontal trim stabilizer that I have also here to trim the horizontal stabilizer. You can see is displayed over here. On the outside you can see the elevator and also the stabilizer, so we climb, descend, and also we can trim the stabilizer or the elevator of the aircraft, also the rudder, make left and right turns, the ailerons over here, spoilers, the flaps are extended as you can see. So you will see all the functions of the Boeing 787 and it's all the instruments over here. So we have the primary flight display, as you can see. The displays are the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed. I need to set up a little bit the lighting, the display. So we have also an aircraft is coming up for landing over here. It's a Boeing 737-800, as you can see. Here it comes, and that's a touchdown. So you will see how we control the flight controls over here, the horizontal trim stabilizer, the thrust levers for the engines, the displays. So we have a lot of functions to explain from the displays over here. So we have here for the displays, as you can see, the primary flight display. You can see the airspeed indicated right now, the airspeed selected from the autopilot flight director system panel. The actual airspeed right now is 0. So we have the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute. All the signals of the trigonometric angles increase can climb, descend. So you see this needle moving up when we climb, like 500, 1000, 1500, 2000, 3000, 6000 feet per minute, or descend. Also you see the altitude increase or decrease. Same way also the airspeed indicated over here. We have the pitch ladder, the flight director crossbars, the wings level of the aircraft over here also display. We have also You can see also we have we have the pitch ladder over here. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down. Also the bang roll in flight like 5, 15, 20, 30, 45, 67 degrees. The flight director, the level up symbol for where is the vertical point of the horizon. Also the takeoff ground over here. The SSI. Also the display here, you can see the horizontal and vertical navigation display. You will see the aircraft flying and flying above the ground later. Also the altitude set from the autopilot over here. So you can see the distance from Zurich Lszh airport over here to EDTL. This is Düsseldorf, is 60 nautical miles. We have 40, 60, 20, 80 nautical miles, the maximum range. So you can see also, if we look up closer to the navigation display, you can see the terrain around you, in front of you, and also over here the vertical, you will see some mountains in front of us when we fly like 10 nautical miles away from us. Right now we are 1,430 feet over here in the Swiss Alps. You can see the terrain elevation around you, the runway over here, the taxiway over here, and also I will show you later the elevation of the mountains is 1,430 feet, as displayed by the barometric pressure altitude. So you see here, you will look up closer or further away, you will see more red and green and yellow colors. Also more airports, the blue airports. We can see also waypoints if we change or stay together. So you can see here is Germany, France and Switzerland. Also the elevation of the terrain is of 5,000 with red and 1,600 with amber. So we can reset again over here. So very important, the navigation display. Also you can see the instruments here, the autopilot, flight director system panel. You can see the autopilot, the airspeed, the autopilot engage, disengage, the auto throttle left and right, the flight director, the LNAV, VNAV, later vertical navigation, the heading and the bank angle limit, the vertical rate of climb descent, and the altitude. We're gonna use the word localizer, the approach for autoland. We're gonna use them later. You can see system, CDU, navigation display info, cyclist communication, the engines, expand over here, the map displays. Also you can see the barometric pressure, the plan, range, weather, traffic, terrain on the display. You can see inches of mercury or hectopascals. So this is you can increase or decrease the barometric altitude, the elevation we are located, by switching, increasing or decreasing the barometric altitude like this. So you will see a higher altitude or lower altitude displayed over here, more or less than 1,430. Right now you can see also the head-up display displays the same things like the primary flight display. Also the engines indication, the flight management computer. We're gonna input all the data we need later for creating a flight plan, the mouse pad for the flight management computer and the keyboard. We have the stabilizer here, trim cutoff switch for the Boeing 787. We can cut off the stabilizer auto trim function. I will talk to you later. We have also the alternate. We have the parking brakes set over here, this handle also. Stabilizer trim like this. This way you pitch the aircraft nose up, trim the elevator up, and also this way you trim the elevator down and pitch the nose of the aircraft down. So this is how you balance the aircraft, by trimming its elevator position or its horizontal stabilizer in some other aircraft like this. So we have the manual control also. I'll show you because this is part of the flight controls. I'll talk to you about the flight controls now. So you can see this way we trim the elevator up, pitch the nose of the aircraft up, and this way we trim the elevator down and pitch the aircraft nose down. As we fly, very easy. You can see the tag as it says elevator. Trim, left click down and right click up. Over here we have the autopilot disengage, head up declutter, the airspeeds for the flaps, extend and retract. Also the yoke here, you can control the aircraft direction in flight, left and right turns, using the control wheel like this, as you can see, and also have control of the vertical column, so make turns left and right like this. Also use the rudder pedals for the vertical rudder. You can see the rudder pedals movement, the vertical rudder, and the nose wheel steering in the ground with the vertical rudder, and also the toe brakes. We have the rudder pedals assigned. So you can see the elevator control, climb, descent, the rudder, aileron, spoilers. I will talk to you in a couple of minutes. Stabilizer trim also, the left and the right stabilizer, and elevators. So we have also here the thrust levers for the left and the right engine. As you can see, the thrust reverser, pull up this handle and reverse. You deploy the thrust reversers. We have the auto throttle disconnect, the takeoff ground switch, either one, the fuel control left and right engine. You can let the fuel flow, start the engines and also shut them down. The fire extinguishers, pull out and switch for the left and the right engine. Also the transporter, radio and communication panel. Over here the rudder position, and also high frequency satellite. Over here communications, transporter. So this is the pedestal. Also we can see here some displays, left and right engine, the N1, which is the low speed starters, have low pressure compressor and turbine of the turbofan, which is engine exhaust gas temperature per engine, and 2, which is the high speed starters, have high pressure compressor and turbine of the turbofan, which is engine, the fuel flow per engine per 1000 kilograms, all the pressure, all temperature, all quantity, and the vibration of the N2 stage of the engine. We have also the gross weight for takeoff, the fuel on board, the saturated air temperature, the fuel temperature right now. Here you can see also we have the flaps position, the landing gear, extend and retract, the alternate gear, the lock override. As you can see, the stabilizer trim, the rudder trim, and the cabin pressurization, that means pressurizer usually from the engines, or the APU. So you can see cabin altitude, rate of climb, descent. We can pressurize the cabin of the aircraft as we climb and we descend. We use also the outflow valves over here for pressurization. As you can see, we have it in the auto, in the manual. We're gonna have to use the outflow valves, open and close, press open and close, and pressurizer, the pressurize as we climb or we descend over here. Also we have pressurizer coming from the engines for wing and engine and the ice over here. Hydraulic fluid tanks pressurization, air conditioning, oxygen ventilation, and other systems. So hydraulic fluid tanks need pressurized air. Also we have the APU here, the auxiliary power unit, a smaller turbine we're gonna use to start the engines. When we shut them down, it's gonna give us pressurized air. You're gonna see it coming from here, from this section, and electric power to start the engines. So we have over here also, so you see cabin pressurization here. As we climb and we descend, it's gonna increase from 0 differential pressure to 7.8. When we climb at 43 or 45,000 feet, the cabin altitude should be 6, 7 or 8,000 feet, and the differential pressure 7.8 to 8 psi. Also select landing altitude. You see the valves here, outflow position, open and close. So we have the landing gear, alternate gear over here, lock override. As you can see, auto brakes for ejected takeoff. So if you set the auto brakes for ejected takeoff, you will display RTO over here, or set for landing later when we need. So we see flaps, stabilizer trim. I show you the stabilizer trim is over here, the one we use here with these switches or these switches. We have also the auto trim function and the cutoff switch for the stabilizer trim. So this is a fly-by-wire aircraft. It has a flight control computers over here. As you can see, primary flight control computers in the auto position. The hydraulics. So we have a failure of the hydraulic system that will affect the primary flight control computers will be degraded over here from normal to alternator direct mode. You have to come down here. This will affect the movement of the motors over here, the function of the motors. For the stabilizer trim, for the auto trim function, we're gonna have the manual trim and also elevator. So we have to disengage like this. For all Boeing 737, we're gonna lose the auto trim function. This is so this is for all Boeing Boeing aircraft. Actually, it's if you have a failure of some hydraulics system, that will affect also the motors that control the auto trim function. Because this fly-by-wire aircraft, we're gonna have a degradement of the flight control computers. It's similar to the Airbus aircraft. We have similar kind of failures and degradements in the flight control computers, but here we have to disconnect the auto trim function if we need. So we're gonna fly manually the trim switches position. So you're gonna see here, I just show you the overhead panel, the hydraulics over here, how we're gonna use them. You can see the hydraulic pumps. If we have failure of the hydraulics, it will degrade the flight control computers. Also the auto trim, the autopilot will be. Γεια σου, τι κάνεις, καλά? Ο Γρηγόρης τι κάνει, θα έρθει? 8, εντάξει. So we're gonna have to come down here. This is for Boeing 737, Boeing 747, Boeing 757, Boeing 777, Boeing 787, and Boeing Boeing 787 also. You open this red guarded switch you see here from normal to cut off, and you disconnect the auto trim function, and you fly on the manual trim switch over here. So you can see the cutoff, either left or right, stabilizer, normal, and cutoff. So cutoff either one. You use the pitch trim alternate or manual, normal, manual like this. So this way you trim the elevator up, you pitch the aircraft nose up. This way you trim the elevator down, you pitch the aircraft nose down. You see how many degrees over here. You can use also the this switch is more convenient when you fly. Trim the elevator up and down like this manually, and the control wheel while holding the control wheel and the yoke. So you see how many degrees here. Right now it's 5 degrees, is inside the green path for takeoff. The rudder trim is 0, the flaps position 30 degrees. So we can trim down a little bit the stabilizer trim. We need to trim it down a little bit, a few degrees like this. So a few degrees down. It will display after a couple of minutes like 4.7 or something. 4.7. We need like 4.25. So this is the stabilizer over here, left and right. This is the explanation for the stabilizer trimming. I will show you the rest of the flight controls now, how I use the side stick, and also I will talk to you about Newton physics, aeronautical and aerospace engineering, and the air transport pilot license theory, the commercial pilot license theory, the TPL theory and CPL theory. We need to know for the flight dynamics, aerodynamics of the aircraft when we fly, to apply the principles of flight. So you can see again the computer, the flight controls that I have here. So I'll start seeing from the outside view. What do we need to know for the aircraft before we go into flight? So you can see here the surface area of the wings. Hold the weight of the aircraft when the aircraft is flying. The weight is divided over the surface area of the wings. Also, you can see the great arcs down here, where is the center of pressure in the wings, the maximum lift component, where the thrust also from the engines overcomes drag. So we have jet engines that pull forward the aircraft. We have below the wings when we fly. The airflow is moving slower from the Bernoulli fluid, so we have higher pressure, like 200-300 kilometers an hour. That pressurize the aircraft wings and weight up into the air. Also above, using the Bernoulli fluids, the airflow is moving much faster. That it sucks the aircraft weight and wings up into the air. So we have the engines here. You can see we have the left and the right wing fuel tank, the center tank. We have the fuel booster pumps over here and the long high pressure fuel valves. Also we have the fuel supply for the engines is coming down here through this way usually inside the combustion chamber. So we have the high pressure compressor turbine here, the jet engine, and the low pressure compressor turbine, the front fan. So you can see we have two flows. One is from the front fan and one is from the inner core of the high pressure compressor and turbine and the combustion chamber. So we have also the pressurizer from the engines is coming out to the manifolds over here for the hydraulic fluid tanks, and also cabin pressurization, oxygen, and wing and engine ice is coming back to the leading edge of the wings and the nozzles of the engines. So we have here the minor aerodynamic chord position where the maximum aerodynamic lift occurs, 33% of the Mach, where the center of pressure moving back and forth, also the center of gravity here. So we have the airflow becomes detached here where the minor aerodynamic chord is, and we have the stall of the wings. So you see when you fly the aircraft, you're gonna see the stall. It will be displayed here with a red and yellow indication below the airspeed, and also you see the angle of stall. So we need to push the side stick or yoke down, and also advance the thrust levers forward to make a stall avoidance. So we have here the minor aerodynamic chord. We have the center of gravity here, and also the yawing axis of the aircraft. So the yawing axis, to yaw the aircraft, you use the rudder in flight with the rudder pedals over here, also the forward nozzle. So you use the rudder pedals like this, left and right, to control the rudder in flight. So it's very easy. I have it also in my side stick. So we use also the forward nozzle. It's controlled automatically from the computer together with the rudder, from 0 knots up to 45 knots, like in takeoff or in taxiing, like 80 kilometers an hour, 72 kilometers an hour. The forward nozzle will deflect up to 76 degrees, also using the tiller. Then as we accelerate faster above 45 knots or 72 kilometers an hour, the rudder becomes aerodynamically effective. So the computer will limit the forward nozzle to like from 76 degrees to 7.6 degrees left and right. Also, when we accelerate even faster above 80 knots or 144 kilometers an hour, the computer automatically will lock the forward nozzle to 0 deflection or small deflection like half or 1 degree. So we have only the rudder above 144 kilometers an hour, like in takeoff in 250-300 kilometers an hour, or in landing, also in flying. So when we land, we have first the rudder, then the nozzle becomes activated automatically from the computer. We don't need to do nothing. So this is the rudder pedals, the tiller, and also we have the tow brakes. So we have the horizontal component here from wingtip to wingtip. The pitch axis, we use here the side stick to climb and descend like this. So climb and descend, use the side stick control like in the Airbus, the pitch axis, so you can see maybe not so much good view. Also in the Boeing we have the yoke back and forth. So it's the same function, same flight control. So we have one more axis here. It's from nose to tail. It's the longitudinal axis. We make left and right turns like this, ailerons and spoilers. Also you can see aileron, spoilers and flaperons in the Boeing also. One more flight control in the Airbus. So we use aerodynamic lift between the left and right wing by deflecting these flight controls to make left and right turns. So we have all flight controls together, coordinated flight. So you can see also speed brakes extended or flaps here extended. So we have a flight spoiler. So we have the control wheel, make left and right turns in the Boeing aircraft like this, very easy. Also I'm gonna show you one more view now of the flight controls of the Boeing 787. Then I will continue with the rest of the system, so you will see a better view, more close-up, more clear view. So you can see here we have again the controls. You can see the side stick that I use, so we can climb, we can descend, we can make turns. Turns to the right, turns to the left like this. So climb, descend, make turns. Also rudder pedals. So you can see how you should also have the thrust over here, actuate the thrust over here, forward and aft. The stabilizer trim, we have also the autopilot disengage for the Airbus and the side stick priority, the push to top button. So you can see climb and descend like this, very easy. Make turns right and left. So this is the explanation for the flight controls. As you can see of the aircraft, you can see both sides are interconnected in the Boeing, move together. We need an override force. So we're gonna see also the outside view a little bit, and then we go for the flight management computer. So you can see again left and right turns, aileron, spoilers like this, rudder, elevator. So we have full flight controls, both aircraft, Boeing and Airbus. Similar flight controls as you can see. So we go now inside for the rest of the systems. This is enough for the flight controls lesson now. We go now for the flight management computer very quickly. I'm gonna set up the flight management computer, input all the data we need for this flight and create a route. It can be used also from the autopilot or flight manually. So you can see here I have again the mouse pad. We need mouse pad and keyboard for the displays. Over here you can see the display. Now the mouse pad, we have the flight management computer, the keyboard, the index over here. So we can load either one, identity takeoff, flight plans. So I would show you this view over here is better for creating the flight plan over here. So you see control quadrant. So we have identity, position, performance. Identity is a Boeing 787, 900 Z aircraft, GNX engines. Position, Lszh, align the IRS, inertial reference system, laser gyroscopes and geographic North Pole, magnetic North Pole, longitude and latitude performance. 0 fuel weight, fuel on board, gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel freezing temperature, cruising center of gravity, departure and arrival, Lszh airport and back to Lszh airport, copy paste. Also clear runway 14. So we have departures over here. Runway, we can select runway 10, 14, 16, 28, 32, select runway 14 and Zui to Alpha. These are the seats that are in the departure waypoints and fixes. Arrivals over here set runway 16, 2834, 14, ILS 16, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we select ILS 14, Transamity and trans over here, the stars that determine arrival waypoints and fixes, Negri 1 Alpha. So we have the legs. First waypoint, the route is displayed with blue, not yet activated. Zui, climb to the Negri, trans Almiki, then descend, approach Landung 0701. So we set the reserve fuel, 0 fuel weight plus fuel on board, gross weight for takeoff. Cruising altitude 35,300 feet above the sea level, 100%. The cost index, cruising center of gravity, and fuel freezing temperature over here, as you can see. So we have the legs now will be activated, displayed with purple and white. So it's the first waypoint, 136 heading, 2 nautical miles, 250 knots, 1,900 feet, Zui, 1356 nautical miles, 301 knots, 6,000. Climb to the Negria heading 071, 26 nautical miles from Zui over here. So you can change or add something. Mativ, make a right turn, 12 nautical miles from Negria, 301 knots, flight level to D 2200, Zui. Mativ, Amiki, Zui again, 0701, 186,000. Then TRA, Osnem, runway 14, approach and landing. We have takeoff, go around also, flaps 15 degrees for takeoff. This is the takeoff reference, runway 14, V1, V rotate, V2 gross weight. So we have the route, departure, alternate route, VNAV, progress, and communication, hold over a waypoint, legs fix, setup fix, and also tune ILS, the navigation radio, VOR ADF. So we have virtual cockpit again, as you can see. So you're gonna see two things over here. Before going to takeoff, you can see here the displays. So you see the navigation display. We have the purple color, which is the flight plan we have created. Over here you can see the stars for approach, the runway, also the vertical here, as we're gonna be flying vertically, so we can see closer or further away, the route even closer. You can see the runway now, you can see the airport map like this, the whole airport map over here. We'll look up closer a little bit more. We can see the runways and the taxiways. So this is the taxiway. The aircraft is on the runway we're gonna use for takeoff, the other runway. Also the terrain, the aircraft, the terrain in front of us when fly also. This is for navigation, you can see. So this is the runway we're gonna use for takeoff and landing. Our own taxiway right now is over here displayed where the aircraft is. Also you can see from the outside, also the terrain in front of us when flying, so you can see taxiway, runway, position, terrain on the display. This is for navigation purposes for the aircraft. Also we can look over here the other map over here. You can see the aircraft symbol. Also look over the flight plan like this, the runway used for takeoff, landing when flying, other airports over here. So we have to start the APU over here. We're gonna make an engine start demonstration. You can see the left and the right side is 100 200 volts, 400 Hz frequency, APU generator, battery. So So we start the APU like this. Primary flight control computer is in the auto position. Air data computer, flight control surfaces, battery, towing power, FD door, passenger oxygen over here, window sheet, rammer turbine backup hydraulics, and left and right engine driven hydraulics. If we turn off primary demand, you see the fault, then back on and to the auto position. We have the wing and engine the eyes over here on an auto position. Also cabin pressurization, manual climb descent, also valves, pressurizer from engines and from APU. We have also here the recorders, cargo and APU fire, electronic engine control for the engines with the auto start system. We can start the engines like this. You will see C mode. Also we can dump some fuel, select the nozzles, how much fuel to remain, fuel booster pumps, crossfeed valves over here, left and right wing, center. The crossfeed valve will turn it out, feed either engine with other pump and balance the fuel between the left and the right wing like this, as you can see. So this is all the overhead. We need to see now a little bit more, start the lights over here and see a little bit more more or less a part of the systems. So we have the systems here. You can see the hydraulics, the APU is running, the oxygen liquid cooling over here, as you can see, the electric left and right IDZ, the drive connected, volts, battery charge and discharge, battery in aberrants, the load side. Also the APU is running with green. Hydraulic, where the hydraulic fluid goes, which systems use hydraulic fluid over here. Also you can see primary demand, left and right engine driving, electric C1 and C2, the quantity of the hydraulic fluid and the pressure 5100 for each generator, shut-off valves and isolation valves. Also the fuel, left and right wing fuel, left and right wing fuel tank, center tank, 11,000, 11,000, 11,000, total 34,000. 11 high pressure fuel valves from the center, fuel booster pumps. The APU from the left wing is in the DC motor. Minus 37 degrees, you can see the minimum fuel temperature over here, below which the fuel will freeze. Also the FAREX, the fuel authority, these electronic control computers that control the engine function and the fuel control and other systems. One installed per engine gearbox to avoid redundancies. So the FAREX also control the transfer of fuel from the left and right wing and the center tank to the engines components to heat up the fuel in flight so it won't freeze. Also return transfer back into the left and right wing or the center tank. Also the lubricant and the oil. So you can see the minimum fuel temperature when we fly higher, like 30 or 40,000 feet. The fuel maybe is gonna be freezing. So we have the automatic. Right now is minus 6 degrees, minus 37 minimum fuel temperature. So this automatic, we don't need to do nothing on the transfer of fuel. Also the crossfeed valve, you can feed either engine without the pump and balance the fuel between the left and right wing. Pressurize air from the engines and or the APU. The doors are closed, the cabin can be pressurized. Gear, temperature of the brakes over here and pressure of the tires. Flight controls over here, left and right wing like this. Also you can see this is one of the last things. Flight controls, also the tail, climb descent, the rudder pedals. You see the deflection and the position of the stabilizer trim. FS display, status, maintenance over here, systems and circuit breakers, and also we have checklist what we need to do, normal menu, before start, after start, descent, approach and landing. So this is the latest checklist, the last thing. And now we go for starting the engines, navigation display over here. So we turn off both engines like this, fuel control in the off position, fuel valves, and you see the fault messages will appear over here in the display. Also the engines going off. So we need to restart the engines. The hydraulics going off like this. So we go in the overhead and restart. Over here it's gonna admit pressurizer right now from the APU. You see the reconfiguration with yellow switches, lights in the overhead. And also here we have pressurizer only coming from the APU. 17% of the N2, which is high speed starters, have high press compressor turbine of the turbofan, but anything above 20% we can start other fuel flow. So you can see we have only pressurizer right now, so we start the fuel valves both in the on in the run position. And it's gonna give the auto start on. So we have both left and right auto start. You can see everything now is turning on because there is fuel and pressurizer into the engine starter. Both of them. So above 50%, you see also the yellow messages going off. At 62% we're gonna be having running engines, so we can go for takeoff. One last thing, flaps set for takeoff, speed brakes arm, and set out the autopilot panel over here. So you see the LNAV and VNAV over here, the flight director off. We'll disarm all modes. We need the flight director on, auto throttle, left and right if we need. Also the airspeed like this, we can set autopilot disengage like this. Heading, bank angle limit, and heading we're gonna set the runway heading for takeoff and for landing. Vertical rate of climb, descent over here, vertical speed. We can descend like this, you see the minus. All levels off, you see the zeros. Also climb, you see the plus sign. So we have also the altitude over here set thousands, like this, 35,000, and then hundreds. So we can set, now we're ready for takeoff. We take the clearance from the air traffic control, advance the thrust levers, and taxi into position. So we take the clearance from the air traffic control. The runway is open for us. Zio. So we're gonna align with the center line. Also. Align with the center line. So this is Thomas.Hatsios, the German American pilot flying the Boeing 787. Thank you for staying with me. I just start now the flight, full manual flight. So advance the thrust levers of the Boeing 787 jet aircraft. So stay with me until the end part of the video. Thrust levers to take off go on. Also here, maximum takeoff, first stabilize. So we press the side stick down of the yoke until 80 knots, along with the center line using the rudder pedals. So we have 100 knots. Also we're gonna rotate at V1, V2, we rotate. So we pitch up 9 degrees for rotation, landing gear up, positive rate of climb. We don't need to pitch up too much the aircraft. We have enough positive rate. We can also leave the hands off from the flight controls, no problem, without connecting the autopilot on an airplane to do that. As we're climbing, we can see. So you can see here we are 1,100, 2,000 200 400 above the sea level, but 4000 above the sea, 2400 above the ground, 200 knots. The airspeed 199 now. The wind direction and speed 5 knots. In front of us, we climb with 5000 feet per minute. You can see the climb symbol. Also the terrain, red, green, yellow, the flight plan, all the waypoints and the purple line. We need to follow the ILS, the runway localizer, the stall speed also here. So we look even further away, we will see more terrain like this. The engines also. So look up closer, like this. You can see the green is the horizontal here, the flight plan, the runway, and also below us you can see the aircraft is here, the aircraft symbol, like this as we climb, and the altitude above the ground level. We are 6,200, 300, 400 feet above the ground, like this. We keep climbing. 6,600. You can see this green line is the terrain below us, and we are at 8,000 plus feet above the sea level, 8,500, so it's 7,000 feet. Now it goes off. So here we go. We need to start the turn. So you see outside, we depart the Zurich, the runway. So we make the first turn now. We should already have done the turn, but I delayed for explanations of the systems displays. So we keep climbing, and we have like 15 more minutes to go back to the airport. Keep climbing for the flight plan here. So you can see all the air data, the flight plan, the airspeed, the stall speed, the wind. Now it's 22 knots, 12,000 feet. We have the purple needle as we climb. Follow the climb rate. So the climb rate continues, and we have over here, see a little bit further, closer. You can see the purple line again. So look outside. You see the Boeing 787 over here climbing for the flight plan. So you see this beautiful aircraft, the Boeing 787. Very beautiful wings and fuselage. Also the beautiful view. You can see the Zurich around us, and the Switzerland, the Swiss Alps, the Germany, my homeland, in front of you, and the France in this side. Oh, we need a little bit more to the left. Follow the flight plan here, as you can see. Very beautiful view. Need to follow this purple line over to Zui. We can override the intercept and fly straight to Zui. If we make a little bit left turn like this and then align the aircraft, we're gonna align with this line and make a right turn later, as you see. So this is the aircraft cockpit after takeoff, as you can see. Hope you like it. Switches. So this is a beautiful Dreamliner aircraft. As you can see, beautiful wings, the galactic view also. We need to follow both sides of the flight plan. As you can see, here is the most extreme waypoint we can go into right now. It's almost close. You can see very close actually. Now we have more wind to Germany, Düsseldorf, and now over here the other display, so we can have both displays for navigation. And now the autopilot set at the engines also. Here we're gonna level off for a couple of minutes, follow the flight plan. We can also decrease the rate of climb, so we're gonna make a turn right now. As you can see, manual turn. We keep flying manually. Also use a little bit right rudder, which helps to align a little bit faster. Now left rudder, leveling off. So now we're flying more level. We're gonna make a turn in a couple of minutes, so we follow, as you can see, these waypoints now. You need to make a little bit to the left like this. It's gonna like it for the flight director. We have the Nigri at 21 nautical miles away, as you can see, 21.6.5. So this is the outermost waypoint we can reach. Also you can see the vertical over here, the climb altitude we have reached over here, and now versus the horizontal. So we're gonna start the turn in a couple of minutes. So here we are. We have also the frozen vapors, as you can see, the chemtrails. You can see this way is Germany. We are flying very close, the lakes over here, the Swiss Alps. So we're gonna start the turn now of the aircraft. So this is Germany, Bayern Munich, my homeland, and we make a turn now. We're gonna look a bit closer now. Five, 2, and we have like 14 more minutes to go back home, so we have enough time, I believe, for the video record. We need to make a turn over here, manual, keep flying manually. We can use less thrust. Over here we don't need so much thrust right now. So here we turn. You can see we overflying Bayern Munich, Germany here, and now the lakes, beautiful lakes. So it's Boeing 787, 23,000 feet above the ground level, above the sea level. Keep climbing. The France, the Italy here, and the Swiss Alps. Also the frozen vapors. So this is very beautiful view. Make the turn, 34,000, and we need to align here with the flight plan again one more time. So we are very close now to going back home. Use more idle thrust, leveling off, keep flying level like this. We can connect also the autopilot now if we need. So you see we're flying level like this, both sides, both displays. And also we have the flight director here. Is not yet autopilot connected, so we're gonna connect the autopilot. We have not much time. Airspeed and nav, decrease the rate of climb. And we need also connect the next waypoint, Zui over here. So we're gonna override here a waypoint right now, connect the Zui like this. So we're gonna be flying straight to the airport, to the final approach and landing for the airport. So now we have the autopilot engaged like this, as you can see. So you see autopilot connected, AP on, the airspeed, the altitude, the climbing, and we need to follow this purple line again, these waypoints. Also you can see here the airspeed, the altitude we're at. So we have the AP autopilot on like this. Also the displays here for the autopilot are on both sides. So we have to follow these waypoints one by one. You can see also the vertical, what it displays with the autopilot connected like this, horizontal, and the primary flight display over here, and now in vertical speed. So we need to add a little bit more thrust, I believe. That's more up, that's some airspeed. So here we are, we have 10 more minutes. So here we are, overflying here this area. We're gonna start the descent. So we are overflying Switzerland, as you can see. We have the galactic view, very beautiful. The Boeing 787. So keep flying level with the autopilot connected. So you can see here we have the Switzerland, Germany behind us, Bayern Munich, and the France in this side. So we're gonna start the descent now. We're much closer for the descent now. We can start it. So to initiate the descent, select the lower altitude over here. And also the rate of descent increase. So you can see airspeed, heading, altitude, over here in vertical speed, autopilot and auto throttle engaged. So we now descend with the autopilot automatically. You can use a bit more idle thrust and speed brakes extended to increase the rate of descent. So here we go, descending. So here is our descent with the autopilot engaged, as you can see. The cockpit as we descend. So we have over here, is a bit more idle thrust. You can see now the waypoints, we follow the airspeed. We need to decrease the airspeed. We have Mach 0.6, 19,000 feet, and this is where we're gonna descend. With this airspeed, we need to decrease the airspeed a little bit to idle position as we are descending. So here's our descent with the autopilot, as you can see. Autopilot engaged. Over here all the displays and the flight plan we have. So we need to also disconnect the autopilot now, fly manually. A little bit faster descent over here. And we have 7 more minutes left for the approach and landing. So here you can see the arc of descent. We need to approach through this way. The airspeed autopilot disconnected like this. Also the waypoints we need to follow now is Osnem. over here, so we are very closer to the Osnam waypoint, like this. So now we start the turn, manual turn for approach like this, and we have 6 more minutes left. So here's the turn, manual turn. Six more minutes. Auto throttle off. Use a bit more airspeed whenever we need as we are descending. So we're gonna be leveling off here for alignment with the runway, set line. So you can see the horizon over here, symbol. We almost align with the runway. We have the runway over here, the extension to the runway on the navigation display. So you can see Boeing 787 as we descend. We need a little bit left, moving to the left. You can see also the displays over here for approach. The other side display, we're gonna cross through the runway position over here. Landing gear down. So you can see we're very close for the landing. Also flaps. Use a bit more flaps. A little bit more descent rate, and we need to align over here with the runway. Use right rudder, like now, right rudder pedal for this alignment. So we have the center line at some airspeed right now. We have 4 more minutes for approach and landing, like this. So here's the position we have. Here we go, a little bit less thrust, more flaps if we need. So we have some wing cast, some side wing over here as we descend manually. So we need to align with the side wing and the wing cast. Add a little bit more airspeed, more thrust like this manually. So we have the Lszh localizer right now. As you can see all the information, the glide slope, we are below the glide slope. The altitude, the runway in front of us, so we can follow just the localizer if we have no visibility. Make a not to land usually, so add a little bit thrust, align with the vertical glide slope. Over here we need to whiten to red for this approach. So we have some side wing cast, we need to cramp the aircraft with the rudder pedals. Here we have some side wing like this. A little bit right rudder now, a little bit left rudder now. We're gonna level off for the flare, as you're gonna see. We need to red and to white for the landing. Follow to red and to white, align with the horizontal tail, also used for leveling off for the flare. So we have to red to white. We need to use idle thrust now. A level off for the flare. As you can see, very beautiful flare and touchdown, idle thrust. So we're gonna touch down very smoothly, very beautiful, very professional. Gorgeous landing. Align a little bit with the center line, parking brakes, and also thrust reverser over here. So we use idle and thrust reverse, full thrust reverse here for slowing down the aircraft. So we're slowing down right now, as you can see. We made very beautiful thrust reversers. Very beautiful landing. So we made it. Gorgeous landing. Also the landing gear nozzle over here. So that was Thomas.Hatsios, the German American pilot flying the Boeing 787-900 to the night flight. Thank you very much for watching me. I'll see you next time, next flight. So I keep explaining a little bit more about the landing of the Boeing 787. Very gorgeous landing. You just watch it. Very smooth. So I'll see you next video. Thank you for watching me. So you see here everything in the cockpit. We have idle, thrust reverse if we need. So you see the thrust reverse. Also use idle again and reverse. You see the reverse is engaged over here. Autopilot we're gonna use. We're gonna see a little bit the landing gear here. You see the nozzle is perfectly safe. There is no breakage of any system. The landing gear and the nozzle is starting up the way it should be. You see landing gear, or there is no broken wheels or tires like this from this flight.